Well, students, today we are going to discuss about an organic compound which frightens the most dangerous reptile in the world, that is snake. Yes, we all are afraid of the snakes. But in chemistry, we have an organic compound which can get rid of the snakes, which can keep away the snakes from our homes. In ancient Indian villages, this compound was used as snake repellent under the name carbolic acid. But in chemistry, we call this compound as phenol. So students, today's class is about phenol. We'll discuss phenol in detail in this class. You see here, the snake is there, it displayed on a TV screen, and the moment phenol in, snake out. It was one of the practice adopted by villagers in ancient times. So now question comes, what is phenol and how it look like and how to obtain phenol from different sources? We'll answer all these questions right now. The answers are displayed on a TV screen. Phenol is naturally found in decaying dead organic matters like rotting vegetables and in coal. The German chemist Runge isolated phenol from coal tar in 1834 and named as carbulsar. What does it mean? Carbo, I mean coal, all oil and sir acid. So coal, oil, acid or carbolic acid. In 1843, French chemist Charles Goddard coined the name phenol, and phenol it was so named because originally it was named phene related to benzene, then all because OH is present. So that is phenol. Phenol is primarily used to synthesize plastics. Phenol and its chemical derivatives are essential production of polycarbonates, epoxies, bakelite, nylon, detergents and numerous pharmaceutical drugs. So students, our discussion will be phenol. I hope you will enjoy the class, and after the class you have the total command over phenol and you can answer almost all questions asked in phenol. So let's start the class. Students, be attentive, enjoy the class. First we will discuss the structure of the phenol. Structure, you see this is displayed on a TV screen. Here OH is directly attached to benzene. So phenols are the class of the organic compound in which OH is directly attached to benzene. I repeat, phenols are the class of the organic compound in which hydroxyl group, that is OH, directly attached to benzene. See here the oxygen which is sp2 hybridized attached to sp2 hybridized carbon of benzene. In fact, all this is carbonate of benzene are sp2 hybridized, displayed on a TV screen. Its IPAC name benzenol and very popularly known by the ancient Indian villagers carbolic acid too. So this is structure of the phenol. Now there are so many questions arises. Number one, can be phenol called an alcohol? Answer is straightway no. Phenol never called an alcohol because in alcohol OH group is directly attached to aliphatic carbon. But here you see OH group is directly attached to benzene ring. Next question arises, can it be called an aromatic alcohol? Once again no. Why? Because in aromatic alcohol there must be a carbon atom, at least one carbon atom between the benzene and OH group. So that's the difference here. Phenols are the different class. So these are the class of the organic compound in which OH is directly attached to benzene. So students, what are phenols? Now you got the answer. Phenols are the class of the organic compound in which OH is directly attached to benzene. And the simplest member of this class is phenol, which is displayed on a TV screen, that is benzenol or carbolic acid. So let's start the discussion about the phenol. So next part of this class is classification of phenol. How to classify phenol? Like alcohols, phenols are classified into three classes depending upon the number of OH groups present on the benzene ring. Number 1, monohydric phenol, dihydric phenol, that is displayed here, 2 OH groups. So, here the name of this compound is catechol, very popularly known by this common name, catechol. Then trihydric phenol, here also displayed, there are 3 OH groups, so it is called trihydric phenol. This is the classification of phenol. So, they are classified into 3 classes, monohydric, dihydric and trihydric phenol, which is displayed on your TV screen. So, you have some idea right now. Next part, nomenclature. Nomenclature of phenol, naming of phenols. So, how to name phenols? In phenol, OH is present, OH is directly attached to benzening. So, hence, OH must be given the higher priority, because in the nomenclature priority table, you know, OH placed higher in the table. So, OH must be assigned number 1 and the other substituent assigned lower number. For example, it is 2-methyl phenol. Let me write also here in the whiteboard, 2-methyl phenol, how to name the phenol here. This is OH, this is methyl, number 1 this one, because OH is the principal function. This is number 2, so it is substituent first, 2-methyl, then comes the parent compound phenol. It is also known by very popular common name orthocresol. It is better known by this name, orthocresol. It is popularly known by this name. Then meta-isomer, it is 1, 2, 3. So, 3 is on the third carbon methyl is present. So, locand is 3 and the substituent name is methyl, 3-methyl phenol, and very popularly known by this common name, metacresol. Then the para-isomer. So, now you can name it. What the name? Students, what the name of this compound? You got the answer now. You can name it. Yes, I am damn sure you can name it. It is 4, yes, 4-methyl phenol. And what is the common name? Yes, it is para-cresol. This is the nomenclature of monohydric phenols. Let me give one more example here. Sorry. So, now you can name it. What is the IPAC name of this compound? 2-nitrophenol or orthonitrophenol, 2-nitrophenol. Next one, 3-nitrophenol. And you can name it now. I am sure you can name it. It is 4-nitrophenol or para-nitrophenol. Is that clear now? So, this is nomenclature of monohydric phenols. Now, I am asking questions. Students, be attentive. I am asking a question to you. You tell me, what is the IPAC name of this compound? Can you name it? You see, here functional groups are different. There are 2 functional groups, and CHO has higher priority than OH groups in nomenclature priority table. You know this. So, what do you do with the name? Can you call it phenol? No, because the higher priority is given to CHO. So, this can't be called phenol. This is benzaldehyde and OH is the substituents. So, which will be given number 1? Number 1 is this one and this is number 2. Why? CHO has higher priority in the nomenclature priority table given by IPAC, IPAC. So, it is 2-hydroxy benzaldehyde. Is that clear, students? This is the IUPAC name now. You got this. So this is 2-hydroxybenzylate. It is not on phenol. Now tell me what is the IUPAC name of this compound? Another questions for you. My first question is, can you call it phenol? You know, phenols are the class of the organic compound in which OH is directly attached to benzene. You see, here OH is not directly attached to benzene. So can you call it phenol? No, it can't be called phenol. This is an aromatic alcohol. This is an aromatic alcohol. Got it? Yes. So what is the name of this compound? This is phenyl methanol. Here phenyl is substituents. Phenyl methanol is the derivative of alcohol, aryl derivative. Okay. So this is the nomenclature of monohydric phenols. Now let's see what the nomenclature of dihydric phenols. This is dihydric phenol. So dihydric phenol, can you name it? Can you assign names to the dihydric phenol here? It is 1, 2. So benzene 1,2 diol. Benzene 1,2 diol. You see, is there. But in phenol, if you go for the IUPAC name, this is benzenol. Is not here, but is present here. Why? Because while attaching secondary suffix, this is secondary suffix. As you know, IUPAC name usually, IUPAC name of a compound usually have 3 parts: root word, primary suffix, secondary suffix. While attaching secondary suffix to the primary suffix, you must keep in mind, if the secondary suffix begins with a vowel, you have to drop E of the primary suffix. So primary suffix, I am dropping E here because the secondary suffix OL begins with a vowel. That is why it is benzenol. E is not here. But here secondary suffix begins with a consonant D. That is why E is present. Benzene 1,2 diol. Is that clear? It is very popularly known by common name. That you must know the common name, that is catechol. This is catechol. Can you name this compound? The IUPAC name very simple. You can name it benzene 1,3 diol, and very popularly known by the common name resorcinol, also called resorcinol, common name. Next isomer, per isomer, it is hydroquinone, common name, hydroquinone. What is this? Hydroquinone. What the IUPAC name? It is benzene 1,4 diol. Got it? So this is the nomenclature of dihydric phenols. Okay. Similarly, what the nomenclature of trihydric phenol? Let's attempt some questions of trihydric phenol. Can you name it, students? You can name it. Very simple. 1, 2, 3. It is benzene 1, 2, 3 triol. Okay, this is benzene 1, 2, 3 triol, and very popularly known by the common name pyrogalol. Pyrogalol. Do you know that? Alkaline pyrogalol. What is alkaline pyrogalol? Pyrogalol plus alkali. Alkali, we mean those bases which are soluble in water. Alkaline pyrogalol is used to absorb oxygen gas. It is used to absorb oxygen gas, alkaline pyrogalol. So this is pyrogalol, very popular common name. So students, you got the IPAC name of this trihydric phenol, that is benzene 1,2,3-triol, which is also known by the very popular common name pyrogalol, which is used to absorb oxygen with alkali. Another compound of trihydric phenol, the IPAC name of this compound, you can assign the IPAC name, it is 1, 2, 3, 4. You can't start 1 from here as per the lowest atom locant rule in nomenclature. So it is benzene 1, 2, 4 triol, and what is its common name? Hydroxyquinol. Okay, so this is the IPAC name of the next isomer of trihydric phenol. Another isomer, you can name it benzene 1, 2, 3, 4, 5, 6. So benzene, yes, benzene. Yes, I got the answer. I am listening. You are saying that 1, 3, 5 triol. Yes, you name it correct. This is benzene 1,3,5 triol. Okay, so this is about the nomenclature of trihydric phenol and the phenols. The next part is methods of preparation of phenol. Methods of preparation of phenol, very important from the point of view of CHSE 2021. The first method of preparation which we are going to discuss is Dow process. First method of preparation is of phenol, the Dow process. So what is Dow process? This is the method in which chlorobenzene is treated with aqueous sodium hydroxide under drastic condition to give sodium phenoxide, which upon acidification gives phenol. I repeat, here chlorobenzene treated with aqueous sodium hydroxide, 8% sodium hydroxide under drastic condition. Why drastic condition? I will tell. Under drastic conditions to give sodium phenoxide, and which upon acidification gives phenol. Okay, so let's see what is Dow process, and let me ask one more question here. Why it is called Dow process? Is it the name of a scientist? No, it's the Dow Chemical Company of USA, which first used this method to synthesize phenol on a large scale. So that is called Dow process. The Dow Chemical Company of USA, they adopted this method. So this is chlorobenzene. Now it is treated with 8% NaOH. You can say aqueous NaOH. Under drastic conditions. What is drastic condition here? High temperature, 350 degrees centigrade, and under high pressure, that is 300 atmospheric pressure. 300 atmospheric pressure. You see, can you achieve 300 atmospheric pressure in a laboratory? No. That is why it is an industrial process. On a large scale, phenol can be prepared in this method, 300 atmospheric pressure. So what it gives here? Sodium phenoxide. Sodium phenoxide. Sodium Na plus, phenoxide. Phenoxide, O minus, ID means minus, phenoxide, sodium phenoxide, which upon acidification with dilute HCl gives phenol. This is Dow process. Now question comes, why drastic conditions? You have this idea, you have already learnt in haloarenes. In the previous lecture, you know this. Chlorobenzene undergoes nucleophilic substitution only under drastic conditions, or chlorobenzene is very less reactive towards nucleophile. Why? Because in chlorobenzene, this carbon chlorine has partial double bond character through resonance. Got it? I repeat, chlorobenzene has partial double bond character, that is PDCH. PDCH. What is PDCH? Partial double bond character. This is partial double bond character. And why partial double bond character? Through resonance. So that is why chlorobenzene undergoes nucleophilic substitution under drastic conditions. And what type of mechanism it is? What type of mechanism it is? This is nucleophilic substitution reaction, ordinary nucleophilic substitution reaction? No. This is different. Aromatic nucleophilic substitution reaction, ARSN reactions, aromatic nucleophilic substitution reactions. There are two types of aromatic nucleophilic substitution reactions. One is elimination addition mechanism, which it follows. Elimination addition mechanism, through this reaction takes place through elimination addition mechanism. What is that? Elimination of HCl to give benzene. This is benzene. Elimination of HCl to give benzene, then addition of nucleophile OH minus ion. Elimination addition mechanism. Second mechanism, addition elimination mechanism. What is this? Addition of nucleophile OH minus ion followed by elimination of leaving group Cl minus ion. So this also follows addition elimination mechanism. But phenol is believed to be formed by elimination addition mechanism, that is through benzene. Okay. So this is Dow process. Now let's see what type of questions can be asked based on these reactions. That is important. What questions we can expect here? What are the expected questions? See, the expected questions are displayed on our TV screen. Number one, what is Dow process? Very simple. Chlorobenzene when treated with aqueous sodium hydroxide under drastic condition, I mean 350 degrees centigrade and 300 atm pressure, gives sodium phenoxide, which upon acidification gives phenol. That is Dow process. Next question, say, what happens when chlorobenzene is treated with aqueous sodium hydroxide under drastic conditions followed by acidification? Same reaction, the same reaction here. Okay, that is chlorobenzene, aqueous NaOH, drastic condition, sodium phenoxide, upon acidification gives phenol. Now you see, again what type of question can be asked? Third question is there. How will you prepare phenol from benzene? How will you prepare phenol from benzene? I am not started with benzene here. I have started with chlorobenzene, but question it is already asked in your CHS exam. So this is important here. How will you prepare phenol from benzene? Let's see. The chlorobenzene, how to prepare phenol from benzene. I am starting with benzene now. Benzene is the starting material here. So benzene when treated with chlorine in presence of a Lewis acid catalyst AlCl3. Benzene when treated with chlorine in presence of Lewis acid catalyst AlCl3 gives chlorobenzene. You know this. This is the example of electrophilic substitution reactions. You know this. This is the example of electrophilic substitution reactions. Which one is electrophile here? Question comes, which one is electrophile? You know that. Electrophile is Cl plus. So benzene with chlorine in presence of AlCl3 gives chlorobenzene. This is the example of electrophilic substitution. Then nucleophilic substitution reaction under drastic conditions to give this one. Usually elimination addition mechanism. Through benzene, we will discuss benzene later. The chlorobenzene with aqueous NaOH under drastic condition gives sodium phenoxide, then upon acidification gives dilute HCl. This is the third question. You can prepare phenol from the chlorobenzene here. Very simple. Okay, you see, this same reaction can be asked in 3 different ways. Another 2 methods are also there of asking question. Okay, we'll discuss that. So, we are discussing the Dow's process, the method of preparation of phenol. We have discussed 3 types of asking question based on Dow's process. Let me refresh you, that is what is Dow process, what happens when chlorobenzene is treated with aqueous sodium hydroxide under drastic conditions followed by acidification. The second question can be asked based on the Dow process. Third question was how you prepare phenol from benzene. I have told you that there are also 2 more methods to ask question based on Dow process. So, the 2 questions are, one of the questions displayed on your TV screen. If you are given chlorobenzene, aqueous sodium hydroxide and dilute hydrochloric acid, how will you prepare phenol? You know the same reactions, same answer, chlorobenzene with aqueous sodium hydroxide. What do you mean by aqueous sodium hydroxide? 8% sodium hydroxide solution, and that with sodium hydroxide under drastic condition, 350 degree centigrade and under 300 atm pressure, it gives sodium phenoxide, and which upon acidification gives phenol. You know that, but the style of asking question is different. I have shown you the 4 methods of asking questions based on Dow process. Next question. You see, this question can also be expected. It is given chlorobenzene, it is mentioned aqueous NaOH, 350 degree centigrade and 300 atm pressure. The first product is sodium phenoxide, you know that, and upon acidification of dilute HCl gives B. See, the different method of asking questions. Another method, you see, this is reverse method. This is one of the important method. Here, the product is given. From the product, you have to predict the reactants. See, the same reactions. Phenol is there as the product, and it is the compound B. The phenol is obtained from the compound B upon acidification with dilute HCl. So, what the compound B? You know that? Yes, students. Yes. It is sodium phenoxide, correct. And what is A then? A is phenol. You know that. So, you see, I have shown you different ways of asking question based on a particular reactions. Okay. So, this is Dow process over. Next method of preparation of phenol from benzene diazonium chloride. We can also prepare phenol from benzene diazonium chloride. So, next method is from benzene diazonium chloride, short form BDC, benzene diazonium chloride. What is benzene diazonium chloride? How to get benzene diazonium chloride? The first question arises here. How to get benzene diazonium chloride? Is it readily available or we can prepare it? We can prepare it in laboratory. From which compound we can prepare benzene diazonium chloride? From aniline. This is aniline. Aromatic amine. This is aromatic amine, aniline. So, how to get BDC from aniline? Aniline when treated with nitrous acid. I repeat, nitrous acid. But is it available in laboratory? No, because nitrous acid is unstable, not available in laboratory. So, how to get nitrous acid? Nitrous acid is prepared in situ. What is situ? In solution. So, nitrous acid is prepared in solution. So, how from mixture of NaNO2 and dilute HCl, this gives, you see, NaNO2 plus HCl products HNO2 and NaCl. This is nitrous acid, but unfortunately it is not available in our laboratory as it is unstable. So, it is prepared in solution from sodium nitrate and dilute HCl. So, aniline when treated with sodium nitrate and dilute HCl gives BDC, benzene diazonium chloride, but BDC is unstable. Once again, BDC is unstable. Why? Now, nitrogen is a good living group. Nitrogen is a good living group. So, BDC is unstable. So, at high temperature, even at room temperature. At room temperature, I mean beyond 5 degrees centigrade, BDC decomposes to give nitrogen gas and chlorobenzene. That is why we have to very concerned about the temperature. Temperature must be given here, temperature must be mentioned here. Temperature, what the temperature here? 0 to 5 degrees centigrade. At very low temperature, BDC benzene diazonium chloride exists. So temperature must be mentioned. That BDC benzene diazonium chloride, when treated with warm water at 80 degrees centigrade. Warm water, I am not saying boiling water. It is warm water. Boiling water, temperature 100 degrees centigrade. It is warm water below 100 degrees centigrade. Gives phenol. This is the second method of preparation of phenol. Okay. Now question can be asked based on this reaction also. There are different methods of asking questions. I have already told you that after this class you can answer almost all the questions asked in phenol. See, this reaction can be asked in 4 different ways. There are 4 methods of asking questions. Number 1, see, displayed on your TV screen. What happens when aniline is treated with mixture of sodium nitrite and hydrochloric acid followed by treatment with warm water? Aniline treated with NaNO2HCl, that is nitrous acid, to give benzene diazonium chloride. Do you know what the structure of benzene diazonium chloride? Let me show that. You must have some idea about that. Benzene diazonium chloride. Don't worry, you have a chapter that is diazonium chloride BDC. There is a chapter in your syllabus, benzene diazonium chloride, and this is the structure of the benzene diazonium chloride. Say nitrogen has got a positive charge. Why nitrogen has got a positive charge? Trick is, if you'll find nitrogen has 4 bonds, must have a positive charge. Students, I repeat, when nitrogen has 4 covalent bonds, must have a positive charge. So that is why there is a positive charge. See, the nitrogen has 4 covalent bonds, so positive charge. Benzene diazonium chloride. How it is obtained? From aniline. So what the question? Now you can answer. See, what happens when aniline treated with mixture of sodium nitrate and hydrochloric acid at low temperature? BDC. BDC treated with warm water. What it gives? Phenol. This is the method of asking questions. The question can be expected in your exam. Next method of asking question. If you are given aniline, sodium nitrite, hydrochloric acid and warm water, how will you prepare phenol? Same reaction. The aniline with sodium nitrate and HCl, benzene diazonium chloride with warm water gives phenol. That's, you write that this reaction. This is, just write the reactions. You have to mention the name also here. Below this compound, what you have to write? BDC, benzene diazonium chloride. And below this compound you have to write aniline. That's all. This is the second method of asking questions. Now you see, same reaction you see. It is displayed on your TV screen. What I have written here on the whiteboard, the same reaction I have written. NaNO2 dilute HCl, 0 to 5 degrees centigrade, BDC, warm water, phenol. Reverse method of asking questions. I have already told you this is important, because once you are acquainted with this method of solving question reverse way, you can have the total command over the organic reactant and the reagents. Okay. See, the phenol is the product, it is given, and you have been asked what is B when treated with warm water. Whenever you find the B treated with warm water gives phenol, B is BDC, benzene diazonium chloride. And B from A, whenever you find NaNO2 dilute HCl or HNO2, obviously it is this related to that diazonium salts. So BDC from A what is A? Then aniline. Very simple. See, the reactions, a particular reaction can be solved, can be asked in 4 different ways, 4 or 5 different ways. Any doubt, students? Here one more question can be asked, that what is BDC? It is benzene diazonium chloride. How it is obtained? From aniline. Well, students, Next method of preparation of phenol is from benzene sulfonic acid. I repeat, benzene sulfonic acid. This was the method which was used commercially in Germany in the year 1890. Phenol can be prepared benzene sulfonic acid. So, how can you prepare phenol from the benzene sulfonic acid? Benzene sulfonic acid, when fused with sodium hydroxide at 350 degrees centigrade, it gives sodium phenoxide. Okay, you got sodium phenoxide. So, sodium phenoxide upon acidification, you know what will the product, that is phenol. Okay, so let's see how will you prepare that phenol from benzene sulfonic acid. I will not start from the benzene sulfonic acid, I will start from the benzene. Let us first prepare benzene sulfonic acid. This is benzene. You know this circle? Remember, benzene does not have any pi bond. Benzene does not have any pi bonds. Benzene has delocalized 6 pi electron. We are writing the pi bond structure of benzene just to explain the reactions. Otherwise, benzene does not have any pi bond. This is the actual structure of benzene, and the circle symbolizes 6 pi electrons. Sorry. Phenol, when heated with oleum, benzene when heated with oleum, that is H2SO7 or mixture of H2SO4 and SO3, when heated with oleum, it gives benzene sulfonic acid. Another example of electrophilic substitution reactions. I repeat, electrophilic substitution reactions, and this is called aromatic sulfonation, and in aromatic sulfonation, remember this, electrophile is SO3, neutral electrophile, SO3, neutral electrophile. This is SO3, trigonal planar shape with 3 pi bonds and 3 sigma bonds. So, this is benzene sulfonic acid. Benzene sulfonic acid, when fused with sodium hydroxide, when it is fused with sodium hydroxide, it gives, it gives sodium benzene sulfonate. That sodium benzene sulfonate, when fused with sodium hydroxide, it gives sodium phenoxide, This is sodium benzene sulfonate. Now it is fused with sodium hydroxide at 350 degrees centigrade. It gives sodium phenoxide and Na2SO3 plus water, sodium sulfide. So, sodium phenoxide, from sodium phenoxide, you know how to prepare phenol. You know this. Sodium phenoxide, if sodium phenoxide is given to you, you can readily prepare phenol. You know this, you learned this method in the first reaction also. So, sodium phenoxide upon acidification, dilute H2SO4, it gives phenol. we can prepare phenol in this way also. I have told you this was the first commercial method of preparation of phenol in Germany in the year 1890, that they have started preparing phenol from benzene sulfonic acid. But I have shown you how to prepare phenol from benzene. Okay. Again, based on this reaction, what are the question expected? What the type of question we can expect in CHSC exam? Let's see. Number one question displayed on your TV screen. Just have a look. What happens when benzene sulfonic acid is fused with sodium hydroxide followed by acidification? This is the reaction. You know this reaction. Okay, benzene sulfonic acid is fused with sodium hydroxide followed by acidification. I have already written the reactions in the whiteboard. So, the question, if the question asked to this one, you can answer it. Next method of asking question, you see, if you are given benzene sulfonic acid, fused sodium hydroxide and dilute sulfuric acid, how to prepare phenol? You are given benzene sulfonic acid, or the question can also be asked to like this. If you are given benzene, oleum, NaOH, sodium hydroxide and dilute sulfuric acid, how to prepare phenol? This one I have already written the reaction on the whiteboard. On the whiteboard it is clearly visible. Okay. So, what is the question? What I am asking here? If you are given benzene, not benzene sulfonic acid, oleum, fused sodium hydroxide and dilute sulfuric acid. Fused means molten sodium hydroxide. Fused sodium hydroxide is molten sodium hydroxide. How to prepare phenol? Answer is this one. Next method of asking questions. Same reaction, again asking in a different way here. So, here the question asked to that identify A, B and C. So, you know the benzene sulfonic acid NaOH, A is sodium benzene sulfonate, you have to name A, that is sodium benzene sulfonate, you have to write the structure. Then with 2 NaOH, when fused with NaOH, it gives B. What is B? That is sodium phenoxide. With dilute sulfuric acid, what it gives? It gives phenol. Third method of asking questions. Fourth method, you say, reverse way. I have already told you this is important, because if you start adopting this method to solve questions, you will have a total command over the organic reactions. You see, here you have to think about the reactant. We do not have the reactant here. If the reactant is given, anybody can answer. But here the pressure is on your mind. What should be the reactant which with treatment with dilute sulfuric acid gives phenol? Very simple. C must be salt of the phenol, sodium phenoxide. Then B with fused NaOH. When B treated with fused NaOH to give sodium phenoxide, obviously what is B then? Now B is sodium benzene sulfonate. Then what is A? Which on treatment with oleum, when heated with oleum gives B, so obviously A is benzene. So, this is the methods of asking questions based on a particular reactions. I have shown you the 4 methods of asking questions based on the preparation of phenol from benzene sulfonic acids. This is the third method of preparations. Fourth method of preparation is cumene hydroperoxide method. I repeat, cumene hydroperoxide method. What is cumene hydroperoxide method? What is cumene first? Cumene is isopropyl benzene. I repeat, isopropyl benzene is called cumene. So, how to get isopropyl benzene? What the structure? Let us see. First, cumene preparation. Once again, I am taking the starting reactant benzene. When benzene is heated with propene in presence of phosphoric acid, H3PO4, phosphoric acid at 250 degrees centigrade, it gives isopropyl benzene. What it gives? Yes, it is isopropyl benzene. This is isopropyl group. This is benzene, isopropyl benzene. and very popularly known by this common name called cumin. Cumin. And what the method of preparation? What the name of the method of preparation here? Cumin hydroperoxide method. This is cumin. Okay. So, cumin when oxidized by the oxygen, when oxidized by oxygen in this temperature range 95 to 135 degrees centigrade, when cumin is oxidized, it gives cumin hydroperoxide. This is cumin hydro. Why hydro? Because hydrogen is there. This is hydrogen. This is peroxide linkage. Cumin hydroperoxide. This one. This cumin hydroperoxide, when heated with 10% H2SO4, 10% dilute sulfuric acid, in this temperature range, that is 50 to 90 degrees centigrade, it gives, see the compound, it gives phenol and an important byproduct acetone. Acetone. So, nowadays, this is the industrial method of preparation of phenol. On a large scale, phenol is prepared by this method nowadays. Okay? So, this is cumin hydroperoxide method, and what the advantage it has got over other methods? See the important byproduct. We have acetone as the important byproduct here. Okay? So, this is the method of preparation of phenol, cumin hydroperoxide method, very important method. What is cumin here? This is isopropyl benzene. Cumin can be obtained from benzene. Benzene when heated with propene. This is the example of Friedel-Crafts alkylation. This one. Friedel-Crafts alkylation. Friedel-Crafts alkylation. What is the alkyl group that is introduced? It is isopropyl. And what is the electrophile here? Because this is the example of electrophilic substitution reaction. Once again, whenever you find benzene, whenever you see benzene, first reaction strikes to our mind is electrophilic substitution reactions. First reaction strikes to our mind is electrophilic substitution reactions. So, benzene with propene gives isopropyl benzene, and electrophile is isopropyl carbocation. This is electrophile. Remember, there is a trick. Whenever you find alkene and acid, a trick I am saying you. Alkene and acid, I repeat, alkene and acid, carbocation is the form. Carbocation is the intermediate. What is the intermediate? Carbocation. So, this is carbocation. This is more stable carbocation. Primary carbocation can't be formed here. This secondary carbocation, this being more stable, it is formed. Now, it gives cumin oxidized to give cumin hydroperoxide, and upon acidification gives phenol and acetone. This is the method of preparation, one of the very important method. What are the questions we can expect here? Let us see what are the expected questions which can be asked in CHSC exam. Number 1, say, just have a look which is displayed on your TV screen. What is cumin hydroperoxide method? This one. Number 2, what happens when cumin or isopropyl benzene is oxidized by air followed by acidification with hot dilute sulfuric acid? This one, once again this one. Same reaction I am asking in a different way. The question are different, but the reaction remains same. Third question, you see, if you are given cumin and hot dilute sulfuric acid, how will you prepare phenol? Cumin oxidized by oxygen of the air, cumin oxidized by oxygen of the air to form cumin hydroperoxide, and when it treated dilute sulfuric acid gives phenol. Now, the reaction based question you see, again displayed on your TV screen, fourth method, benzene given here, propene, same reaction. What is written in the whiteboard is the same reaction displayed on TV screen, and identify A, B, C. What is A? Cumene. What is B? Cumene hydroperoxide. What is C? Acetone. This is the method expected questions. These are the expected questions based on this cumene hydroperoxide method. I have shown you 4 methods of asking questions. Okay. Reverse way is also possible. I can start with phenol also. Okay. So, with this I come to end of the today's class, that is phenol, the structure of the phenol, the classification of phenol, the nomenclature of phenol, and methods of preparation of phenol, and what type of question can be asked. That is also, I have also shown all these methods of asking question based on particular reactions. Okay.